Okay, so this one, probably the hardest one on the test, to write a Verilog module for the circuit shown above in problem 1, and then given an initial state, so then there's a part B for this one as well, given an initial state of 1, 0, 0, and input to green equals 1 and write in equals 1, what is the next state of the circuit? So first let's write the Verilog module. So all Verilog modules start with, actually I think I will type this one, it'll be neater. So you'll start with the word module, then you'll give it a name, so midterm problem 3. And then you'll list your inputs and outputs. So let's go back and look and see what our inputs and outputs were. So we had green, write in, write out, and the clock. Now Q is just used internally. It's not an input or output, and so that does not have to be listed here in this list right here. So we had write in, write out, green, and clock. Then you need to say what your inputs are, and our inputs were write in and clock, and our output is clock. And then we need to define Q as reg, because we're changing it within an always block. We're going to change it within an always block because we're changing it every time the clock changes, and so every time on the positive edge of the clock. So every time we get to the positive edge of the clock, we're going to see if Q needs to change. And since that's happening, since we're changing it, we're looking at when something else changes, which is the clock, and then we're making a change when that happens. We're using an always block. And because we're changing it within an always block, then we define it as reg. And we could define several different variables, but it's all Q. And so we're going to give it as a vectored signal. And there are 3 of them. So if you go back and look, there's Q0, Q1, and Q2. And so we put 2:0. So that means it goes from 0 to 2, 0, 1, and 2. And then, like I said, we're going to use an always block. And so always at, and now we're going to tell it when we want it to do what's in the always block. And we're going to say always at the positive edge of the clock. Okay, so now, no semicolon there. Okay, okay, so now we have a condition, and we're going to do one thing if green is 1, and we're going to do another thing if green is 0. So we can say if, and we could say if green equals 1. We could say that, but you can also just say if green, and that's the same thing. So if green. And by the way, the only thing we're going to have in our always block is an if and an else. And because of that, we don't need to have a begin and end. If we were going to have more things in our always block, we would have a begin and end. And so for our if, we actually need a begin, because we're going to have several things here. So this is when green is 1, it shifts right. So that means Q0 becomes Q1, Q1 becomes Q2, and Q2 becomes right in. And so we use the non-blocking assignment, which means that it's going to use the values that these flip-flops had when you entered the always block. And the non-blocking assignment looks like the less than with the equal sign. So we're going to say Q2 is going to become equal to right in. And Q1 is going to become equal to Q2. And Q0 is going to become equal to Q1. And so, like I said, we use that non-blocking assignment because otherwise we might get in trouble because we might be changing something and then set it so if we change so like we in this first line we changed Q2, but then we make Q1 equal to Q2. Well, we don't want to make Q1 equal to the new value of Q2. We want it to equal the old value of Q2. And so that's why we use the non-blocking assignment. And, okay, so that's what we do if green is 1. Else, we want it just to keep its value. We just want it to stay what it is. And so we could say, then make Q equal to Q, and having Q there without the saying Q0 or Q1 or Q2 is going to do all of them. Now, we don't actually have to do that else statement. If we don't do it, then it'll still work because it doesn't actually change anything. Okay, then we'll get out of the always block. So we're done with the always block. And then we're going to use the assign statement. And the assign statement is going to assign this value, and this will be all the time, unlike the always block, which only does it at the positive edge of the clock. This is a continuous assign statement, and it's going to make right out equal to Q0. So anytime Q0 changes, right out will become equal to Q0. And then after that, we just end our module, and we are done with that one. End module. Okay, so now the second part of the question said, given an initial state of Q2, Q1, Q0 equals 1, 0, 0, and green equals 1 and right in equals 1, what is the next state of this circuit? Okay, so green equals 1, and we know if green equals 1, that was the shift right. So we had our flip-flop here, our flip-flops, and we had 2, 1, 0. I'm not going to draw them all the way out. And this one, so this was 1, this was 0, this was 0. Right in is 1, and right out was, we aren't told right out. Okay, so and then what's the next state of this circuit? So we just want to look, we can just look at what we did right here. And so it's shifting right. So Q2 becomes 1. Q1 is going to become a 1, because this goes here, this goes here, this goes here, and Q0 is going to become 0, and so the next state will be 1, 1, 0.